Today we're going to talk about two very important types of gears in mechanical transmission: involute gears and cycloidal gears. Next, we'll cover their respective advantages and disadvantages, as well as the applications where they are used. In precision machinery, gears can be said to be the backbone of power transmission. Among the many tooth profile curves, involute and cycloidal curves are the most representative and the most widely used, each showing their strengths in different fields. Next, we will focus on their working principles. An involute is actually the trajectory formed by a fixed point on a straight line as the line rolls without slipping around a base circle. This curve is then applied to gears, resulting in what we call an involute gear. Its most significant feature is center distance separability. This means that even if there is a slight deviation in the center distance when installing two gears, the transmission ratio remains extremely stable. This is a very important advantage. It greatly reduces the precision requirements for machining and assembly, thus improving reliability. It is also highly suitable for mass production. Involute gears have other advantages as well. For example, their cutting tools can be standardized. One tool can cut gears with different tooth counts, but the same module. This also saves costs. In addition, the tooth root is relatively thick, so the load carrying capacity is very high. Coupled with easier assembly, it has become the most widely used gear in modern industry. Got it. So, are there any insurmountable disadvantages of involute gears? Of course there are. First, its contact ratio is relatively low, meaning that the contact time of a single pair of teeth is short. Simply increasing the tooth height to improve the contact ratio is not very effective. Therefore, its transmission smoothness is somewhat limited. Moreover, when the number of teeth is small, undercutting is likely to occur during generation machining. This thins the tooth root and weakens its strength. Correction using profile-shifted gears is required, which complicates the design. It is also sensitive to manufacturing errors such as pitch errors, which can easily cause vibration and noise. In addition, the relative sliding between the tooth surfaces is relatively large, resulting in higher friction loss and higher requirements for lubrication. So, what is the principle of a cycloidal gear? A cycloid is the trajectory formed by a point on a rolling circle as the circle rolls without slipping around another fixed circle. If the rolling circle is outside the fixed circle, it is an epicycloid. If it is inside, it is a hypocycloid. The tooth profile of a cycloidal gear consists of one section of epicycloid and one section of hypocycloid. What are the main advantages of cycloidal gears? The biggest highlight of cycloidal gears is their extremely high contact ratio. During transmission, multiple pairs of teeth are in contact at the same time, theoretically up to half the number of teeth. Therefore, the transmission is extremely smooth, with almost no vibration and very low noise. That sounds perfect for equipment with very high requirements for operating precision. Exactly. Furthermore, the contact between the tooth surfaces is mainly rolling, with very little relative sliding. Thus, wear is minimal and efficiency is high. Another major advantage is that no undercutting occurs. So the number of teeth can be made very small, for example, down to 6 teeth, while still maintaining a complete tooth profile and sufficient strength. What are the more challenging issues in the practical application of cycloidal gears? The biggest problem with cycloidal gears is that they have extremely high requirements for center distance accuracy. The transmission ratio is very sensitive to changes in center distance. Even a slight error will cause unstable transmission ratio, resulting in impact, increased noise, and even jamming. Therefore, it has extremely high requirements for manufacturing and assembly precision. It seems that machining and installation are quite troublesome. Is the cost also high? Yes, because the tooth profile is very complex. Special high-precision gear grinding machines and tools must be used. The manufacturing and sharpening of these tools themselves are very difficult. Moreover, one tool can often only process one type of gear and cannot be used universally. Next, let's talk about where each of them is used. Okay. Involute gears can be used in various general machinery, such as automobiles and machine tools. Cycloidal gears, on the other hand, offer extremely smooth transmission and high precision. They are mainly used in precision instruments and RV reducers for robots. RV reducers in robots are a very typical application of cycloidal gears in modern industry. They adopt a cycloidal pin gear mechanism, which fully utilizes the advantages of cycloidal gears: high contact ratio, high rigidity, and small backlash. In addition, through highly precise planet carriers and manufacturing processes, their sensitivity to center distance is compensated. Therefore, they have now become a core component in the joints of industrial robots. They are also irreplaceable in some pumps and flow meters, thanks to their good sealing and uniform flow rate.